Well, good afternoon, good morning, wherever you are. We appreciate you joining us for the third part of this turning webinar series that we have. Today, we're going to be talking about manual programming techniques. And joining me today is Christian Peluche, who will be going first on the demonstration from Autodesk. Then it will be Andy Barney and Phil Jennings from NexGenCAM. And then at the end, we're going to have Christopher Crane from Autodesk. So these four presenters will be going through content. And I wanted to thank them all for their contributions as we get started here. If you aren't familiar with the full Autodesk portfolio of manufacturing, I would like to tell you there's a lot of things going on, all the way from planning and new ways of creating the parts of tomorrow with things like generative design that Autodesk has created to let a computer build a part, getting into the programming, the additive molding CNC tools, which is kind of the heart of what we're talking about today. And then getting out into production with nesting tools and 3D printing tools and different power inspect for inspecting parts as they're being manufactured as they come off the machines. It is a wide and deep portfolio. And one great acquisition that Autodesk just added to this to make it even better, they acquired CAMplete on October 5th of this month. It's a pretty exciting acquisition. If you already are using CAMplete, you're probably pretty excited to hear this news. If you haven't heard of it or you're not aware of it, it is a software for optimization. It's for verification of your code and simulation of your code. Basically, what it does is it takes the code right from the CAM software and delivers it to the machine without a post-processor in place. Anyway, we're very excited about this. I'm sure it'll be a couple months as Autodesk works through the acquisition, and then we'll be able to talk about it early next year with you. There is a certain number of machines that it's already built out for, and I'm sure that list will be growing. When we look at Autodesk, we look at data like CIMData does reporting on the industry, and Autodesk has the largest number of software developers, experts, and consultants that are focused in on this industry at over 600 and growing with the CAMplete acquisition. They've invested well over $1 billion. They also have some neat manufacturing innovation centers. If you're taking a vacation ever to San Francisco, maybe when COVID slows down, they have two fantastic facilities out there. They have a machine shop right on the bay, and they've also got a large museum. So if you're out there with family, it's great. It's right down at One Market and down on the pier. So you can go in and see all this stuff. It's a neat place to stop. They also have another center out in Boston. And while I'm telling you about the fun stuff to go and see and do there, it's great to see that they're innovating, they're investing in innovation. And this is why we're so excited to represent Autodesk and their portfolio together as a winning solution in the market. If you're not familiar with NexGenCAM, we've been Autodesk's #1 CAM partner 5 of the last 6 years. The reason we've been so good is because of our people on the team. The members you're going to see present today all have extensive experience with CNC machines and multiple CAM softwares, so that's what has made us into a great company to work with. We're an authorized training center. We have a lot of classes available if you're a CAM user, a CAD user. You can look, we've got an interactive calendar. We probably do over 50 standard and custom classes a month. So definitely look us up on there. We have some unique solutions around robotics and additive capabilities. So if you want to do things in robotics, like put a milling head on the end of a robot, we have a partnership with a robotics company right in Wisconsin that we do a lot of work with. And it's called Robotic Solutions. We also have additive capabilities. Autodesk has some great 3D printing capabilities, both in PowerMill and another product, NetFab, and a lot of neat projects going on with those products. Also wanted to let you know we're nationwide. We have a big team in the West, a big team in the Central and in the East. And so we're really servicing a lot of customers on a nationwide basis. You can find a lot of information about us just going to our website. You can also call us, and we'd be happy to work with you on CAM and CAD solutions. So here's what we've done so far. We had a webinar on October 8th on advanced turning. October 15th, we did a Swiss programming webinar. And then today we're getting into manual programming. As has been part of the format, we're going to show some different machines, and we're going to show different parts today, just like we have been. But it really comes down to, what are you using? What are your machines? What is the software that you have available, or if you don't have any software available, what type of parts are you cutting? High production parts, low volume parts? We'd love to know that, because it really comes down to looking at your parts and your machines and trying to find a solution for you. We've also been putting content out on YouTube and Facebook from these webinars, so if you want to go see some of the different parts and pieces, they're up there, and we've had a fair number of people viewing them already. So digging into today's webinar, we broke it down into 4 sections. So the first thing we're going to talk about is G-code optimization. So what are the different editors that are available with Autodesk, and how can you best utilize those? The second thing we're going to get into is complex shapes. So if you're building complex shapes, there are times for manual programming, and then there are some things that, wow, if you could just use CAM software or something like that, these complex shapes could be a lot faster. So these are the things that we wouldn't want to program manually. Then we're going to talk about synchronization, and then finish up, I think, which will be a highlight at the end, is automated programming, is the ability to use tools in your shop to take the easy stuff off your plate. It's interesting that we found through some studies that a lot of shops that are producing parts will spend the same amount of time on an easy part as a hard part. And we'd like to change that, so you're focusing more of the time on the harder parts. So digging into G-code optimization, one of the tools that we have is the CIMCO editor. So if you're an HSMWorks customer of Autodesk, you've got access to this editor. And instead of going through this in detail, we are a CIMCO provider. The CIMCO editor does 4 things that we see our customers using a lot, which is the regular editor, the multi-channel editor, and the ability to add macros quickly to your code and building a macro library. There's also backplotting. There's DNC transfer, which is one machine at a time, where you can send your code out to the machine and back. And then also file comparison to see, what's actually happening on your code. You thought you programmed it this way, but how did it actually come together on the machine, and comparing that. So what we did is we just put together about a 6-minute video. It's up on our YouTube channel on CIMCO Highlights if you want to go through that from an Autodesk CAM perspective. Many of you know Bruno Vasconcelos on our team. He's fantastic on support and does training. He put together this video. I wanted to thank him for that. So you could go out, you could go through that pretty quickly. Call us if you have questions. For the multi-channel editor, we're going to have Christian Peluche is going to go over that. He's going to do a live demonstration. That will be our first live demonstration. So there's been a lot of questions in the first 2 over the different products and things that are involved. So one of the products we're showing today is Fusion. It's kind of nice that you've got a CAD package just that comes along with your solutions here. And so Christian's going to go over that briefly, with your ability to have a CAD solution that's relatively easy to use. Often when we're working with CAM users, it's more about CAD for CAM. How can I get the model to the place I want it to be to get the services I want? So at this point, we're going to move into the demonstration. And through this turning webinar series, we have been showing mainly the 2 products in the middle for advanced turning. We've been showing FeatureCAM and PartMaker because they just really are good at the advanced turning. They've been at it for a long time, but we've also been showing Fusion. And were a lot of questions about, well, which one and where. And the nice thing is you can get all of these solutions together in a subscription pricing model that's very cost effective and provides a lot of capability for you and your shop. So with no further ado, I'm going to hand it over to Christian Peluche, and he's going to get into the multi-channel editor first, and then showing you guys some things with building models and getting things ready to produce them.
All right, thanks, Eric. Just gonna go ahead and change the presenter to myself and show my screen. Okay, so we're taking a look here at the part maker turn mill software, which we would use for some of our most advanced turn mill applications. And one of the things I've seen over the years is just the difficulty in manually editing code and the use of things just like Notepad. But PartMaker actually comes with its own editor that allows you to align all the weight codes and then make those edits. And you can see everything line up. And there's no guessing when it comes to, you know, how your weight codes will align, and then you can export that code out to your machine. So let's first take a look at how you actually pull up that editor. So in PartMaker, if we go to View, Preferences, we can go to the NC Program Editor and just tell it that we want to use the multi-channel editor. So once we generate code from the process table in PartMaker, let's go ahead and just generate a quick NC Program view. This is just going to show us a view of all of the channels lined up, and then we can click on in the top right, NC Program Editor, and that's going to bring up the multi-channel editor. Now, I am going to have to change the application real quick to the multi-channel editor on the GoToWebinar, and now you should be able to see the multi-channel editor actually showing on the screen. So this looks just like it does within PartMaker. You can use the Align tool to actually align the weight codes and see everything properly with the appropriate number of channels. As many editors do, there's functions such as a swap function, so maybe swapping G2s and G3s, a replace function for any kind of, you know, maybe you have a spindle speed consistently wrong, you can just use the replace function. And then once all of our edits are made, we can go ahead and just save that off and then bring that onto our machine. Now, similarly, we can do it from PartMaker, but we also can open programs that we've created by hand. So if we go to open, you can see we basically pick from our pre-configured machine list. That shows us the number of channels that are on that machine, and then we can open up the individual files that go along with that program. You can then make your edits, use the functions available such as swap and replace, and then save it off and then run that on your machine. But this is a much simpler editor to use than trying to do multiple channels using something like a Notepad. So just the ability to view all of those channels at the same time. So let's next take a look at, I'm just gonna again change my application, and let's go over to Fusion 360. And we're gonna take a look at a scenario in which you may want to draw a simple part out and then bring it into your software so that you can program from a solid. And with your Fusion with FeatureCAM package, you do get Fusion 360 included in that. So you'd be able to draw out simple parts such as this one and then bring that into your CAM software for programming. So on this part, you can see we have a 1/4 inch diameter on the front. It's 187 in the middle and a 1/2 inch there in the back, about a 1 inch overall length. So let's go ahead and open up a new design, and we'll go through just quickly creating that. So in Fusion, in the Design tab here, we can create a new sketch. We'll pick a plane, and then I'm going to snap to my front plane right here. Now, you can use just a line and then connect those lines together and then later dimension those. Or we could alternatively use something like a rectangle to draw the overall shape, and then we can dimension those. For this part, for instance, I'll draw approximately 1 inch, and then we'll just draw the rest of the shape here, and then we'll use the trim tools and then go ahead and dimension the rest of it. So I'm going to trim off these extra lines here, and then we can add some dimensions to it. So under sketch dimension here, we'll give it our overall length. It's already 1, but we'll put in 1 inch there. The front section here, the length of 0.3, the back 0.1, and then we'll add our diameters to it. So this one right here, and this is going to be the radius, but we can do arithmetic right in the box there. So if that's a 1/4 inch, I could say 0.25 divided by 2. For this one here, 0.187 divided by 2. and then the last one, which is 0.5 divided by 2. So that'll give us our overall shape. Now those lines were longer previously, so we can just trim off any excess that showed up, and then we can go back and add any kind of chamfers or fillets that we want. So if we want to add a fillet to this before we revolve it, under the modify tab here, we have the fillet tool. It's also shown up here. So we can go in here and add those fillets in. Now, as far as the size of these, we'll just put in 10 thousandths. Now, let's say we want to go and add a chamfer to the back. We can simply just use the sketching tool or just drawing a line and put in some dimensions. So I'm just going to draw one on the front and back, and then we'll use the sketch dimension to then give this an angle. So we'll call this a 45, and then we'll give this chamfer a size. So let's say 10 thousandths. And then using the one on the back, we can actually just copy the dimensions that we created from the front. So if I use our dimension and I pull up the angle here, and let's make sure we zoom in and get the right ones. So we got a 45 there, and we've actually already constrained it to the same as the front one, and then we can add a size to this one. So let's say we want this to be the same size as the front. You can just click on a dimension that was already created, and it makes it equal to that dimension. Hit enter, and now you can see it's a function of the first one. So if we change the size of this one to 15 thou, the second one will change with it as well. So at this point, we can go ahead and say finish sketch. We'll go ahead and revolve this shape, first selecting the profile itself, and then the axis that we want to rotate around. Now you'll notice that we didn't actually have to trim off these extra lines on the chamfer. We can go ahead and select those boxes if we want, if we don't want the chamfer, and then we can say okay. So if this is just a lathe part, we can go ahead and put it on the machine at that point. Let's go ahead and just add a simple hole through it. So we'll just create a quick sketch here and then create a circle right on the front to represent a hole. So I'll add a dimension now to this. We'll call this 0625, and then the dimension from here to the end of the part. And then we can take that sketch right there, and then we'll do an extrude. So we'll pull that shape out, and then we'll say 2 sides, and then pull it out this way, and the software knows that it should be a cut. And then we're ready to take that into either FeatureCAM or PartMaker for programming. Now to export this, just File, and we have the export function. And from the drop down here, for either of those softwares, I would suggest using a step file to then take that file into FeatureCAM or PartMaker. And with that, we'll go ahead and transfer over to Andy. So I'm going to go ahead and make you the presenter.
All right, welcome everyone. My name is Andy Barney. I'm with NexGen, formerly of Autodesk. Been with NexGen for about, she's coming up on 2 years now. So we're excited to show you this today. So let's talk about hand coding. A good hand coding person will be able to, do the turn work with their can cycles and doing all those things, and certainly has value, which obviously makes you better at reading G code and all those other things. So what happens when you get into the live tooling world and you start wanting to do something complex, something like this, where we may need to involve some surface milling? So that's what I'm going to talk about today. I'm looking in the attendees list. I see a few familiar names. Kind of cool to see people I've dealt with over the years with Delcam and Autodesk, and I'm seeing you here on the NexGen side of things. So that's pretty cool. All right, so surface milling is complex, right? So this particular part, I've got some color coding going on. This type of stuff you can certainly do with your turning, and that's actually done already, but I've deactivated for the purposes of this demonstration. But what if you need to do some milling work? Now, if you look at this, this probably looks like you could maybe do something with the 2D. Hand code it, write it out, a lot of math and stuff, figuring things out. that's where the CAM software comes into play. So FeatureCAM is sharing the same surface milling that you might find in Power Mill. The technologies, whether they're 3-axis toolpaths or whether we're doing 5-axis simultaneous. Okay, so in this example, I've got want to look at a machine that's got a B-axis, so I'm just going to grab something like this. It's more Seiki that has a B-axis head on it, and that is essentially a 5-axis machine. Okay, so if we were to take a look at the stuff that's in here, we can see the features that I have right here is the turning, and then I've got a surface mill. This one's a Z-level rough. If we take a look at that, that's a pretty common tool path to use for roughing things out. So we're using a flat end mill, some parameters to do that, and we picked certain surfaces. So let's just kind of watch this in action. And during this, I want you to notice the time it takes to calculate something. So it doesn't take a long time, but there is complexity to some of these other tool paths that I'm going to show in a little bit. And so you see this calculated things pretty fast. Sometimes it depends on your PC, but mine's pretty quick. So let's just take a look at if we were just to rough this out. Okay, so if I run just this operation, we can see the stuff FeatureCAM's doing for you. I want you to pay close attention, really, because this is kind of 2D, but look what we've got introduced here. The C-axis rotation during this. Now you can either lock the C-axis by simply checking a box in the feature, or you can leave it active like this. But could you imagine trying to hand code something like this? That's kind of the purpose of what we're talking about. When do you go to CAM? Right, so if you can hand code a lot of your stuff, conversational programming certainly works in a lot of cases, but can you imagine trying to program something like what you're seeing here, by hand, right? A lot of stuff. You can see the scallops it's leaving behind for a tool path to finish up, so there's a lot of stuff going on. So let's just kind of finish through this. We'll see what it does. It's roughing it out, and it's actually programmed one time, and you'll notice it's a Z-level rough, and it's doing the whole thing. It's looking at my stock. I actually have the stock set as the result of the turn part, which is something you can do, which helps you to be more efficient with your tool paths as well, which you're just going to not be able to do by doing it by hand. Okay. Then there's some other tool paths that follow this that are a lot more complex as far as what they do. So you can see this is roughing out those 3 areas where we're getting ready to do the outer shape. And that outer shape has actually got draft to it. So they're not parallel walls. So that's why you see the steps that you see in this particular tool path. So you see you get this nice clean simulation. I just simulated that first portion. Let's take a look at another one. So if we look over here, I've got a swarf tool path coming next. So I'll go ahead and slow this down for you. We'll take a look at that. And so that's actually just cutting this wall right here. Okay, maybe a little heavy right there. We might want to do some sort of semi-finish in there and get that. But you see that. Now we're on to finishing the bottom of this if we desire to do so or need to for the part we're making. So this is like a 3D spiral option that's in here. So it's the same stuff that's in the just regular milling documents is also here, but you notice the C-axis is in play if we want it to be, right? We can certainly lock that, keep rigidity. I'll go show you guys the setting here in just a few minutes, but just want to give you an idea. This was programmed once, and then it's patterned to the other faces. Okay, so we see this repeated 3 times. So you can see that a lot of these have patterned in a swarf that cleaned that wall is patterned. The floor here you see is patterned. There we go. Okay, so and then there's some other things. So let's take a look. This is actually a remachining toolpath using some of the 5-axis capabilities where we're avoiding collisions and such to be able to machine that with a multiple passes with a ball mill down in there. And so you can just imagine if you needed to do something like this, how basic your hand-coded toolpath would be. And obviously with the CAM software, you can do so much more and have so much more of a level of control over all this. We're getting towards the end of the remachining here, and then we'll see the swarf, and then I'm going to be done with this particular thing, and I'll go show you that C-axis checkbox, just how that works real quick. And then I'm going to turn over to Phil to talk about some other things. I'll be back later to talk about some synchronization in FeatureCAM as well. But can you just imagine trying to do something like that? We even gouge check if we have that issue, so on and so forth. Okay, so let me go ahead and kick out. This is a swarf toolpath right here. This one's pretty cool. It's actually going to keep the tool tangent to the walls on the feature. So I'm just going to do a preview of that just to give you an idea what that looks like. We'll not watch the whole thing. And you can see how that toolpath is following. Let me slow that down for you. See it? And in this case, it's actually conventional milling. We can go into the direction of the toolpath and change that really easily in the milling tab. And you could do the whole thing, or you could pattern it like we did here if that's what you want. But the C-axis thing I mentioned a few times, I just want to show you guys on here that some of these toolpaths, you have the ability to do that. So the Spiral 3D wasn't using it, but if we go look at the Z level right here, you see cut with Y-axis instead of the C, so you're getting XYZ instead of XZC code, and so forth. So the capabilities that you have in here are really immense. Something you should consider if you have parts any similar to this. You can run it all on one machine instead of taking it over to do the turn work and then over to the mill, right? And so reducing setup time, etc. All right, so that's what I have for the 3D. I'm going to turn this over to Phil now. He's going to go through his stuff, and see, I'm going to guess that this is you, Phil.
Yep, I got it. Hopefully everybody can see my screen.
Yes, we can see it.
Excellent. So what we have here is just a standard medical screw, bone screw. And on the back end of the bone screw here, let's talk about creating this hexalobe. Again, hand programming this wouldn't be too difficult if you just wanted to create a series of step downs or depth of cuts. But in many cases, the preferred method for doing this hexalobe is to use a helix motion that keeps the tool in contact with the material all the way down through to the bottom of the feature here. So how's that done? In PartMaker SwissCAM, we simply set up for here's my helix entry. I'm taking the 3D profile and I'm projecting it into the 2D window using the project outline feature that comes with the product. And then from there, I'm building a toolpath. It's a standard way to develop a toolpath in PartMaker. It's just a 2D profile. But the key here is that we can use an advanced milling toolpath. You'll turn this feature on and this button opens up, and now I can tell the system to follow the toolpath with a pitch angle or a standard angle. I like to think of it as a pitch, just like a screw. Right now I've got the angle set at 1 degree. And then I'm going to make sure that the axial step, which is my depth of cuts, is larger than the Z depth, so the system knows to start the helix and just continue down to the bottom of the flat here. So the toolpath, when I've got it set up, will look like this. And in this case, I'm just going to not show the stock motion or the sectional guide bushing. We can show that if you want to, but it's going to be a lot easier to see the toolpath run without the guide bushing and the stock motion. So I'll put a small delay in here and kick the toolpath over, and we'll go ahead and run it. So again, using the CAM system, I can quickly and easily produce a helix toolpath. And again, running this by hand would be very difficult. I started my machining, I would say my apprenticeship was started in 1980. I started out on an upright Bridgeport. From there, I moved into NC programming. From there to CNC, CNC into engineering, and engineering into software. Again, doing this by hand would be problematic. Using a CAM system, it's a very simple matter of creating the toolpath and then generating the code for it. Okay, so milling hexalobes in the part maker is a simple strategy. You just need to select it, turn it on, and you've got it. It's the same with broaching. Now, Eric, do you want to use a slide for broaching? Because I actually have a rotary broach feature set up for the sub side.
Oh, just go for it, Phil. Yeah, I think it'd be better to see
I'll
it
show
than
you
any
that.
slide.
Part maker's got different methods for broaching. We can do rotary or wobble broaching, index broaching, and rotary, which is what I have here. So in this case, I'm actually using a cycle group. I'm going to spot it, drill it, and then rotary broach. The advantage of this is that I can create the entire cycle with one tool path. I do not have to create separate tool paths for this. So I've done a spot, drill, and a rotary broach, and in this case, I'm actually using a custom design shape for the hexalobe. I will actually see that custom design shape when I'm using the simulation and the verification option. So with this pattern, let's go ahead and shut that off. Again, we're going to spot it, drill it, and then you can see I'm using the custom broach to broach it. So we have the capability of building custom tools and using those custom tools in the software. Next, let's look at something that I get questions on quite a bit, and doing this again by hand can be problematic. Let's look at segmented threading, okay? How do you set up a thread profile that's larger than the guide bushing length on your Swiss machine? We have a strategy in PartMaker where we will take the pitch of the tool path. In this case, we're working with a 1/4-28 thread, so our pitch is 0.0375. And I'm going to create a scenario where I'm going to move 4 pitches back in Z, and then I'm going to move 1 pitch up in X. I'm going to create a line at an angle that connects the pitch in X to the 4 pitches in Z. That'll be a lead in. And I'll do the same thing on the other side to create the lead out. The next piece of the segmented thread that I want to capture is going to be done the same way, and you'll notice that here I'm actually overlapping the tool path here. So if we look at the second turn, you'll see that the second turn overlaps the first, and the third tool path will do the same thing as far as the threading goes. So if we follow this strategy, we can turn it and then do a partial thread, and we'll feather the tool path out of the thread profile, do the second turn, then again, feather the tool into the cut, make sure that we're matching up our pitch on the threads, and feather out on the back end again, and continue on until we have the thread pattern created. So let's generate the process table. In the process table, I'm going to be turning and threading, turning and threading, turning. In this case, I've got thread relief, then the third thread profile, fourth turn, and the cutoff. So we're going to go into simulation. It's going to show best in what we call our basic simulation. We do have the ability to create full machine sim, but in this case, the view in the basic simulation affords the best opportunity to see how the blend works. So I'm just going to go ahead and slow down the tool path a little bit here with a time delay, and let's go ahead and run this tool path. So we do the first turn. Again, we're trying to keep everything in the guide bushing, and we feather out on the back end of the thread pass. Then we do the second turn, and you can see we're feathering back in and we're blending the contact points. And when we're done, we've got a fully blended thread segment. Now, I recommend at the machine, when you generate your code, let's see, I should have a post loaded. Go ahead and generate some code here. What I like to do here is to make sure that each thread profile has its own offset. So this can be done in 2 ways. I can actually create 4 separate tools in PartMaker, each with its own offset, or I can just hand edit the offset in on the thread profile so that at the machine, I can use my Z offsets to match completely. On modern machines, this probably works just about right out of the box, but if you've got an older machine, you know, your ways may be a little looser, that kind of thing. In the virtual world, everything works perfectly, as you well know, but once you get into the real world, things can happen that are unexpected. So what I like to do is make sure that each thread pass has its own offset value. In case there's a mismatch at the machine, I can quickly correct it just by doing a Z offset on the offset page. Okay. And last but not least, our back turning capabilities. Let's go back. I believe I created a back turn tool. So we do have the capability of creating back turn tools and using them in PartMaker as well. The key here is to make sure you're looking at your material data sheet that comes with the insert and building the insert based off of the information you're going to get from that material data sheet, which I've done in this case. A shape preview shows the back turn tool, and then we can use it either left or right. In this case, I'm using the back turn tool. And let's go ahead and actually make sure that we're showing the stock motion and the sectional guide bushing, and I'll just step the part through. So here's the sectional guide bushing and the back turn tool. And if we wanted to start on the back end and work forward, it's a simple matter of taking the tool path and just reversing the direction, and then starting on the back side and moving it forward. Okay. So that's some of the advanced strategies that a CAM system will give you that programming by hand can be very problematic at, especially things like the hexalobe and the segmented threading. So at this time, I'm just about finished here, so I'm going to send it back to Andy, make Andy the presenter, and Andy can show you some reordering and resynchronization. There you go, Andy.
All right, perfect. Thanks, Phil. All right.
You're
So
welcome.
one of the beautiful things about having this product group that Autodesk has collected, and they're part of this package, is shared technology, right? And so some of the stuff Phil was showing is things that you can actually see sometimes in FeatureCAM, not necessarily the segmented threading or something like that. Those are special to PartMaker. But there are a couple things, like one, for example, before I dig into mine, there is multi-channel editor capabilities. It's actually using the PartMaker multi-channel editor. You just need to have a post processor configured for it and use a configuration file to do that. So that's actually right up here in the corner. If I click here, you'll see this particular post isn't set up for it, so it's a post edit that needs to happen, but it's sharing it. Another thing that you'll see later is Christian will be talking about pinch turning in PartMaker. FeatureCAM also has that ability here, so you can do it right on the type of tool post you want, single or double on rough or finishing work. But what I'm really here for is to talk about synchronization basics when it comes to FeatureCAM, and then you'll hear more about this in PartMaker as well. Okay, so what we're seeing here is basically a list of operations that are done for this part. This is one of my favorite parts to demonstrate. We got face feature in the beginning, a turn on here, hole, some holes on the outside, and then we see, if you look for the green on my screen, you'll see these holes that are highlighting as I hover over on this side, and if I rotate this part around, you'll see some opposing holes. And what I'm going to actually do is drill those at the same time and do some other synchronization. But there's also some subspindle work. So this is an unsynchronized part. This is the tool post tab, formerly the turrets tab if you used FeatureCAM for a while. But I'm looking at the operation view. But the most important thing is time. So when we're synchronizing, we're trying to get our time down. And so if I look at the time view just up here in the upper portion of this, I can see right now an unsynchronized one, what that would take to manufacture this part, estimated time. All of these bars right here, if I scroll my middle mouse wheel, you can see, you can zoom into that. The longer the bar, the longer the length of time the part runs, or the the operation runs. You can see this particular operation starts at 0. It's the beginning of our process, runs for 16.8 seconds, shows some other information about the tool, etc. Over here in this next one, you can see it starts where that left off. We do a tool change if we need to, whatever, and then the length of the tool path is there. And so the longer the bar, the longer the operation. And that's nice, but really this is the meat of what you're looking at. The operation view is where we can go in and make some changes. Okay, so here's my face turn, some holes. You see the lower hole, and then we got a hole down the middle and some other things, and it's color coded as well. You'll notice that all this stuff is done on the main spindle. That's what that symbol on with the spindle to the big side of the spindle on the left there. That's the main spindle, but we also have some orange or yellowish colored features here, or operations I should say, and those are actually done on the sub spindle. So what I'm going to do is just show you some synchronization basics and reduce this time, and then I'm going to actually show you the machine simulation. So it's as simple as drag and drop. So if you use the shift key, you can multiple select these items. I can take these over and I can drag them over into the lower turret. So this is all upper turret work. This is lower turret work. So I'm going to show you a machine that has an upper and lower turret, a main and a sub spindle. Okay, and so you can see those are there. Okay, now if I want to do, maybe I want to do these two over on the lower turret as well. If there are any conflicts, we're going to get some red X's to kind of tell us, hey, you're trying to do stuff at the same time. And that's okay. I'm taking the items that I've identified what I want to do on the lower turret, and then I'll do the synchronization here in a minute. So I'm going to take all this over here as well. Okay, so now down here we see some bars. These bars are your synchronization. The cutoff, when you make a cutoff feature, which we have one here, it has a transfer to the sub spindle. Here's my transfer parameters that you put on the cutoff feature. It's automatically synchronized, and that will happen at the end right where we want it. Now it's up to me to basically fix these problems and get this synchronized and as efficient as possible. So what I'm going to do is I'm going to select the operation I want to be completed before another operation runs. So I'm going to tell the software, wait until this turn feature is completed here. Oh, hang on, my battery is low. I've been having problems with my plug recently. Hopefully that didn't affect that. Okay, all right, pop that in. Okay, so what I want to do is have this wait until, or excuse me, have this complete before we run this hole, for example. So I'm going to select it, hold the control key. So the order you select it does matter. And I'm going to simply do this icon right here, and it tells me set a sync point for turn 2 finish pass before hole 1 drill. So I can click there. You can see we got rid of a couple of those red X's, and so we're looking a little better. But I can't do hole 2 drilling and hole 1 at the same time. You know, there's some conflict there, so the software is helping us to know that right away. I'm going to do a similar thing, and I'm going to synchronize and tell it to wait there. Now we get some kind of warnings about some things, you know, milling operation with the turning, or they're not in the right position, whatever. Okay, so what I'm shooting for basically is I want to make all these holes on here, wait until after this big hole down the middle. Okay, so we've cleared them up, and I look like I'm synchronized. I have no issues. However, I want to make sure that hole 3 and hole 8 is opposing that on the other side, hole 4 and hole 9. So hole 4 will be here, hole 9 will be there. I want them to drill at the same time. So it's very possible that the upper turret could get to and start drilling and complete the drilling before the lower turret gets in position and finishes its drilling. So in order to synchronize those properly, I'm going to take these two and I'm going to say wait until these two are done before you start these two, and then it will time it up nicely so that the drilling happens nice and clean, and we don't have opposing forces breaking drills, doing those type of things. Okay, so that's a basic way to synchronize a part. So let's take a look at what that looks like in an actual machine. So I'm going to go ahead and show this. I mentioned I have an example of an upper and lower turret. Okay, so I'm going to press play on this, If we have any gouges, it will show us as well. I'm going to go ahead and close this for you to give you a little more real estate to see. And I'm going to run this and show you. And if I had done the pinch turning, I would have seen that up here as well, but I did not activate it. So you'll notice on the main side it's working, but it's also working on the sub, just like it would in your machine the first time you run through with the first part. Okay, so you'll see NC code for the process one time, but we're going to simulate through here twice so that you get to see the completed result. And so you can see where I've got the synchronizations in, and right at the end here, I'm going to go show you the actual time that we saved. So you can see C-axis motion. We could again lock that with that checkbox I talked about earlier. So this is a feature we could lock that if we wanted to for rigidity purposes or whatever your needs are. Simple checkbox. You can swap your tools out, whatever you need to do. So it's just like any other area of feature cam in that regard, but we're doing something a lot more complex. So we got our cutoff, the transfer is going to happen, and you'll see that in this case we have a collision, so we would have to deal with that. You know, typically what I've noticed is on a retract, it's a rapid move, and so feature cam thinks that's a collision, which you may be okay with, no big deal. You could have that modified in your cutoff process to be a feed move out and not have that. And so now we're seeing the completed work happening on both sides, and we'll take a look at the NC code in a minute, and then I'll show you the actual time we saved to show you this really complex part and how CAM software definitely benefits you. So you could certainly hand code these items. You could manually synchronize them in a text editor of some sort or whatever, but the drag and drop I showed you in the tool post makes this just really quick and easy. And you can kind of see where you might make a mistake. So also the benefit is you see the mistakes here rather than at your really expensive turn mill machine, right? And so let me show you the new updated time view on this. And I gotta kick it out of simulation here to do so, sorry. And so it went from 7 minutes and I think it was 48 seconds down to 6 minutes, 19 seconds. So you're just basically free money at this point, and really efficient. So that's what I have to show today. So thanks for joining me. I'm gonna kick it back over, I believe it's Christian. Christian, if you're up, you wanna go ahead and grab it, go for it.
Yep, yeah, I'll change it to myself. And let's go back to part maker. Okay, so similar to what Andy was talking about, manually programming weight codes can be quite difficult, especially when we get to machines such as the one we're looking at on the screen here. This one actually has 4 turrets. It's a Nakamura WTW 150. So to line all that up by hand would take quite some time. So let's just take a look real quick at the operations we're going to be doing. So a pinch turning operation, and then after that we're going to cut off, and then you'll see what happens is a pinch milling operation on the sub spindle at the same time as we're facing off the bar on the main side. So we're going to see all 3 of those things happen at the same time. So to do that by hand, manually programming is of course possible, but would take quite some time, and this eliminates a lot of those errors that you might run into. So let's take a look firstly at the actual operation itself for pinch turning and milling. So in PartMaker, the pinch turning operation is set up just as you would any other turning operation. If we go into the strategy itself, here we're doing a contouring strategy where we've selected both roughing and finishing. We've left some material in X and Z for the rough, but the big thing is that we set up 2 different tools for roughing and finishing. So on the rough tool, that is on turret 1. On the finish tool, that's on turret 2. So those are the 2 opposing turrets that we're looking at. And then we've selected the pinch turning button here. So those items put together will give you pinch turning within PartMaker. Now for the pinch milling operation, if I go to this Mill ZY face window, and let's actually just take a look at the model real quick. So what we're doing is we're milling a hex by milling on opposing sides using turrets 3 and 4, and then we're indexing it, doing this 3 times, and that'll give us the hex. So what we have is a face window at 120 degrees, and then one 180 degrees from that, and then we're copying that 2 times at 60 degrees each for a total of 6 sides on the part. Now these operations themselves are fairly simple. It's just a line going straight across the part, but because in the tools themselves, we've chosen one of them being on turret 3, and then let's go to the next face window here, 180 degrees from it, we're using a tool on turret 4. So tool selection is really key here in getting that set up properly. So let's now move on to the process table where this actually happens. So this is the process table, unedited so far. Because we've selected pinch turning from that turning operation, it already put those into a sync group for us. So what's happening is pinch turning on the main, but nothing on the sub. And we can see that with M2, so main 2 processes, S0 with nothing on the sub. So let's go ahead and change this around a little bit to add the pinch milling. So for pinch milling, if we go to these 2 processes, they're 180 degrees from each other, and I open up this mode switch right here, I can tell the sub spindle that I want it to use 2 tools at the same time. So I'll say okay on that one, and now in the process under it, I'll click on that. I'm going to set the same mode, sub spindle mode, machine with 2 tools. So being that they're the exact same mode, and they're right next to each other, if I hit synchronize, the software knows to put those into a sync group together. Let's do one more thing here and actually take these 2 processes and put it under the face operation. So what we want to do is face and pinch mill at the same time. And to do that, we're going to tell the facing operation, we're going to go into the mode switch, and it's just using 1 tool on the main. But on the sub, we're going to be using 2 tools at that time. So we'll say okay, and then we'll go to the next 2 processes that we want in that same sync group, and we'll just add those set modes to be the same. So we'll say main spindle mode, machine with 1 tool, sub spindle's already machining with 2, and then the same thing for the next pinch milling operation, main spindle machining with 1 tool, sub spindle machining with 2 tools. So those are M1, S2, and because they're all 3 next to each other with the same mode, when we hit synchronize, the software knows to put those into a sync group. So the last thing I'm going to do here, open up this set mode for the cutoff, and we'll just do part support on that, and I'll do that at a 1/2 inch, say okay, and synchronize. So now if we look down here at the time chart, what we're seeing is 3 processes happening at the same time on the main and sub spindle, and then we're going to see that pinch turning happening as well before the cutoff. So as you can see, some of the more complex process table scenarios that we have here, especially with something like 4 turrets, being able to utilize the CAM software just to tell the software what we want the machine to do, and then let the software come up with the weight codes on its own. And that's quite a bit easier than having to do this manually. And with that, I'm going to go ahead and switch this over to Chris Crane to talk about some automation.
Thanks, Christian. There we go. And hopefully everybody can see my screen okay.
I can.
Perfect, thanks. All right, guys, thanks again for taking the time to spend with us today. I realize that there is a lot of information coming at you from a lot of different directions. This is all, you know, this could all be revisited at a later time. If you guys want to reach out to the team at NexGenCAM, we'd love to have a deeper conversation with you guys if you see something of interest, okay? And I have a couple different things I want to show today to kind of reinforce the topic of discussion today, okay? So a little bit about me and where I come from. I've been working in this industry for a little over 25 years. I actually started out as a tool and die maker, and back then I started turning handles on manual machines. CNC was around, it wasn't as widespread as it is today. And through the years I've progressed. I came up through automotive. I graduated into some aerospace companies where we used to run punch tape CNC machines, if you can believe that, where editing your program involved a pair of scissors and a piece of tape. Okay, so I've had the journey of kind of following this technology and growing with it as things have evolved and changed. Okay, and interestingly, in the aerospace world that I was working in, I ended up working for a large aerospace company called Smith's Aerospace Components. At the time, one of the largest aerospace tier 1 suppliers for Pratt & Whitney in the world. So they specialized in large rotary jet engine components for helicopters and jets and private planes and things like that. And this is kind of a topic that's near and dear to my heart, because when I started working there, they were one of the first companies in North America to acquire one of the Akuma MacTurn multitasking lathes. And at the time, there wasn't really any software options for programming a machine like this. So the machine basically has a main spindle subspindle. It has a 5-axis milling head up top and a regular lathe turret with Y on the bottom. So when I started programming this, a lot of what I was doing was by hand, and all this synchronization magic that you guys are seeing here today, I used to have to do all that manually. Okay, a lot of the tool paths that I would use, I would create manually, literally at the controller on a keyboard, punching numbers and working that way. With the tools we have today, it offers us a couple of different key benefits that I want to touch on. Number one is the automation. Okay, so you can see how quickly and easily we can generate code, synchronize turrets, and drive the most efficiency out of the machine tools. That is not to say that you can't take existing code that you've invested time in and proven out and kind of embed those into this process. And I want to touch on that a little bit today. So the first thing I want to show is I'm just going to switch gears a little bit. I'm just going to jump to a very quick milling part. Okay, I like to show this one. It lets me point out a couple of key functions about the way FeatureCAM in particular works. So if I were to go and generate the program for this is all done real time. I haven't set anything up. Okay, and if I look at the details of the NC program, the software has picked the tools, the operations, based on the geometry that it sees in the model. Okay, and currently this part takes 11 tools to manufacture. So how did it arrive at this, and what kind of influence can I have over this? The first thing I'm going to do is I'm going to say, well, you know what? I don't have all those tools set up in my machine. So I'm going to very quickly say, these are the machines that I have these are the tools I have in the machine. This is what I have available to program with. And you can see right away, FeatureCAM realizes that there's a problem. So let's just take a minute and kind of open up the hood and look underneath and see how it arrives at all these decisions that it makes. Everything that FeatureCAM does for you automatically comes from a set of attributes. And the key difference here between this and its template is the attribute gives the software answers to questions, whereas the template, you have to give it all of the information, and it's only ever going to be applicable to the one thing that you're doing. If I'm using attributes, I can apply these decisions across a number of different machine tools, across a number of different processes, materials, however you want to mix and match it. Okay, so right now, if I look at this, I'm in the milling section under drilling, and this would apply exactly the same if I was doing on a multitasking lathe where I want to affect a change. Okay, so we know that right now we're only allowed to drill the hole. Okay, so there's more than one way to make a hole. I'm simply going to make a suggestion to the software. Hey, by the way, there's another way to manufacture this. I want you to use the tools that I have, and I want you to go ahead and reprogram this for me using just the tools that are in the machine. Okay, so right away I get the updated result, and if I take up my tool list now, so with the 4 tools that I currently have set up in my machine, go ahead and program that part. Okay, so this is kind of the automation side of things. So how FeatureCAM arrives at the decisions that it does and how it makes these determinations. If we dig a little deeper into here, there's actually 2 options in this field. One is for machining attributes and one is for machining configurations. Think of machining configurations as a set of attributes. Okay, so I can have different configurations for different machine tools. I can have different configurations based on material or the family of parts that I'm programming. Okay, so if I have 2 3-axis mills side by each, one of them is a 12,000 RPM 40 taper racehorse machine, And right next door, I have a 60 taper, 6,000 RPM spindle. Those two machines are mechanically capable of doing the same operations, but you drive them completely different. So I can have different attributes or different configurations of attributes based on the different flavors of parts that I'm working with. Okay, so if you were to dig into my configuration, which is the one that I start with from the beginning, you'll notice that it is identical to the attributes that we were just looking at. And if we wanted to switch over to this is the way we do it by default all the time, and then if you dig down into it, these are all the different combinations of things that I can do just around drill mill. And you can see that there are a lot of different attributes that the user can look at and control. And the idea is we want to do most of the heavy lifting for you, okay? We don't want you to have to repetitively do things over and over and over again to get a result. If you do things like this all the time, we want the system to present that solution to you the first time. So you don't have to go and find a setting or understand every setting in the product to get the end result that you're looking for. Okay, FeatureCAM is very, very good at this. You've seen some really great examples today of how this works. And I just want to take a jump now over into more of a turn mill situation. Okay, so if I were to go in and maybe turn some of this stuff on and just generate a simple little program. Let's do generate the program. If we look at the results, I'm going to end up with some NC code. Okay, so a couple things here. So one of the things I mentioned earlier around reusing code that you guys may have used and use on a regular basis. One really good example of something like that would be perhaps we have a variable program that we load at the start of our programs for boring the jaws, for example. So if I've already created that NC code somewhere, I can very quickly come and say, you know what, at the beginning of this program, I want to include the variable program that I used to bore the jaws for this, so that this program always comes with this job. So the guy who has to set it up, he's already got the code there to bore the jaw. So in this example, I'm using an Akuma variable program to bore the jaws for this particular job. Okay, so you can see I can very quickly just paste that information into the window here. But let's say it's something a little more complex like a broach. Okay, where maybe this particular product doesn't do, you know, a fantastic job at broaching, but we do have NC code that we can use to achieve that. Well, I can store those things into my part library. And this is really cool functionality because I can store FeatureCAM features here. I can do probing routines. I can do NC code that I want to reuse. So for example, here, if I paste this into the software and then go take a look at it, if I dive down into here and take a look at the toolpath that I've created, I have a a full broaching cycle that I may reuse on a number of different parts in my day-to-day work. Okay, so even though we're automating and we're allowing you to very quickly generate complex geometry and shapes and features and toolpaths and all the things that the software does for you, you can still leverage that legacy data that you have in the shop and include it in your way forward into the new way of doing things. Okay, so I wanted to make sure that we touched on that for sure. Okay, like I said, this is a lot of information to digest in a short amount of time, so feel free to reach out to the team at NexGen and make sure that you guys get all the questions, and if you see something interesting, let us know. Okay, so the kind of the last thing that I wanted to touch on, I realize we're running a little bit over, and I appreciate you guys hanging in with me, is when it comes to the machine design file. Okay, so inside of FeatureCAM, if we look at the different modules that are available, FeatureCAM is a very broad-based system capable of driving the vast majority of machines you're going to find in a machine shop. Okay, everything from 5-axis milling, multi-turret, multi-spindle lathes, sliding headstock screw machines, vertical versions of those machines, wire EDM, multiple fixture, think I want to put a whole bunch of parts all over my table and do them all at once, or Tombstone, the horizontal version of that. And then the very last item down the list is this machine design file. Okay, so some of the machine design simulations that you've seen today can be created by the user themselves, or you can work with a partner like NexGenCAM to really dial them in and get a very accurate representation of what your machine tool looks like. Okay, so you can see here I've got all kinds of detail in here, including the touch center. Okay, it may not be important for programming or cutting parts, but you definitely want to make sure you don't run into it. very, very expensive to replace or fix. Okay, so we want to make sure that we build that in. And if we click onto the machine design file here, I've got a list of basically solids. Okay, and these solids make up, you can see there's some hidden things there, like the door. It just gets in my way for the simulation, so I just simply turn it off. Still there if I need it. Okay, and in this menu here, this is where you're going to find a very user-friendly way of determining what parts of this model are used in the simulation, how things relate to each other, how they move, basically parent-child relationships. And you can see if I click on here, I get a nice little interface where I can say, okay, this particular solid is the parent of whichever solid in the list. So you can go through and build this machine simulation yourselves, or again, work with a partner. They're happy to work with you on that as well. When it comes to things like jogging the machine and things like that, you're going to find all of that in this menu. So with that, guys, I'm pretty much used up all my time. I want to make sure that you know, a big thanks to everybody at NexGenCAM for putting this together, and please do reach out if you've seen something you want to take a deeper dive in. And over to you, Eric.
All right, thanks, Chris. Hey guys, just a great mix of technology, a lot of capability here. Obviously, if you're doing manual programming today, you're probably very good at what you do and really, really excellent at it. I hope we've provided some tools in here that you could use to, you know, to augment your skills to do more. I'm trying to present my screen here. So let me know if you can see my screen. Can you guys see that? Hopefully. There we go.
Oh, there you go, Eric. Now
I can see it.
Anyway, hey, this concludes a three-part webinar we've been going through on advanced turning. There's been a lot of good stuff over 3 different sessions. We've got them recorded, so if you want to go through something, or if you want to just talk to us about how you're working today and how you'd like to work in the future. I just got a couple of emails from people that were attending, sending me information like, hey, here's what we're doing. Can you help us? I'll definitely be reaching out to you after this call, so thank you for those. If you'd like to see more stuff like this, go to our YouTube channel. We're releasing things about every week on there where you can see different parts and things being done with the advanced technology Autodesk has to offer. I just want to have a big thank you to all the presenters. We ran a little bit long, and my apologies for showing so much, but I guess we kind of end on a high note. It's kind of like going to a concert and there's an encore. So thank you to everybody. Hope you have a great rest of the day, and reach out to us with any projects that you might have.